Okay, good afternoon class. Okay, so today we're looking at the introduction to algebra, looking at the examples for exercise 1, and exercise 1 is on page 14 and 15. So at this point, we look at the examples on page 13, so we just put the examples page 13. Examples page 13. Okay, and we're looking at the construction of algebraic expressions, the first section of the introduction to algebra topic. Okay. So the first question says, so the example, it says, write an algebraic expression for the following. Okay. So the first one says the sum of x and 3. So if I must write an algebraic expression for this, what would it be? Yes? Addition. How do we know it's addition? It says the sum of. Okay. So that would simply be x plus 3. You all understand? Is there anybody that's confused? You just let me know if you're confused. Okay. Let's look at the next one. You can write as you go along, or I can give you a chance at the end of it to write it down. Okay. Let's look at number 2. Number 2, it says the difference between x and y. What does this tell us here? X must be, yes? More than y. What does that mean in layman's terms, simple terms? What does that mean? X must be bigger than y. Not so. Okay, the value for x must be bigger than y. So if it says the difference between x and y, what would this expression be? X minus, you don't have to put up your hand, you can just call it up. X minus y. You all understand? Yes, sir. Right. Let's look at number 3. Number 3 says the product of x and y. The product of x and y. What would that be? X multiplied by y, which is xy. Okay. Just going back to the sum here. Is x plus 3 equal to 3x? No, why not?
It's not multiplication.
Not multiplication, yes? But why else not? Because they are unlike terms. Okay, we can only add terms if they are like. Okay, they must be of the same nature, with the same variable in this case. Okay. Let's look at the next one. Number 4. The quotient if 3 is divided by x. The quotient if 3 is divided by x. What would that be? 3 divided by x or 0 by x. It's the same thing. You all agree with that? Yes. Any confusion here? No. You mustn't let me know when you're confused. Okay? So we're going to check your homework tomorrow. You mustn't tell me, oh, I didn't do my homework. Just check that you did your homework. Okay. Number 5. Number 5, we are told the number x multiplied by 6. So what would that be? X times 6 increased by 3 plus 3. 6 times x? 6x. So this can be written as 6x plus 3. At this point, either one will get you the full mark. Okay, you guys understand?
Yes, sir.
Alright. Let's carry on. And 6x plus 3 is not 9x, no? Why not? Because it's unlike terms. Okay, the variables are not the same. Okay, like if you got 7y plus 6x, is that going to give you 13xy? No. Why? They are unlike terms. So 6x plus 7y remains 6x plus 7. You guys understand? If you got, what is 5x plus 6x? 11x. Can you see that's now like terms? Can you see that?
Yes, sir.
What is 5x plus 6x squared? Is the variable the same? No. So they are also unlike terms. Can you see that? Whereas that 5x and 6x like terms, 5x and 6x squared are unlike terms. So when we say they are unlike terms, we mean to say the variables are not exactly the same. The variables must be exactly the same. You understand?
Yes, sir.
Just to draw your attention to this here. If you got 5x y plus 6xy, what is this? 11xy. You all agree with that? So what is 5xy plus 6yx? Is it like or unlike terms? So okay, so you're saying it's unlike. Look at it this way. What if you got xy and yx? If x is 2 and y is 3, what's 2 times 3? 6. You know that between x and y is multiplication, eh? Okay. And then this would be 3 times 2. What's 3 times 2? 6. So in other words, xy is the same as yx. You see that, people? xy is the same as yx. So that means to say that 5xy plus 6yx will be 11. So they are like terms. Make sense?
Yes, sir.
Okay. Let's carry on with our lives. In number 6 it says A increased by B. A increased by B will simply be A plus B. And A plus B can be added. Why? Okay. Let's carry on with our lives. It says the square of C. C is where? Nice. You know C is where? C square. Okay. Do you all understand? Okay. What if I had said the square root of C? In the square, then it would have been the square root of C. Not so. But because it says the square of C, they're talking about C squared. Right, you all understand? Let's put your hand in front of your mouth. No? Yes?
Yeah, when you say the square root of C or whatever, do you put like a 3 or 2?
Wait.
Like the pointy part?
The pointy part. If you say the square root of C, you're asking about that number there. Who can tell her what is there if there's nothing? A 3. If there was a 3, I would have put a 3 there. That's a cube root of C. But if there's nothing, there's a 2. Square and square. Okay. You won't get the first root of something because the first root of something is that. That's why if there's nothing written here, then we know there's a 2. Make sense? Alright. Then it says 3 times P. 3 times P. 3 times P is going to be? It will be 3 multiplied by P. Or 3P. Okay, as you know, if you just write 3P, between 3 and P is? Times multiplication. You will understand? Let's carry on. Number 9. Number 9 says subtract y from the sum of subtract y from the sum of 5 and x. Yes, Michael?
So you first do the sum
Yeah, why? Because that follows from, yes, whatever follows from you right first. So it will be the sum of 5 and, so what do I write here? 5 plus x. Why 5 plus x? Because it's talking about the sum. Okay, and then?
And you minus 9.
One. Minus 1. So you say subtract y from the sum of 5 and x. Okay, do you guys understand? Right, nice, well done. Number 10. Chester is 4 years old. Okay? Chester is 4 years old. William is 4 years older. How old is William? K plus 4. You all agree with that? For those of you who don't understand, if Chester was 10 years old, how old is William? 40. 10 plus 4. If Chester was 100, William is 104. Was 4 years older. Just adding 4. So what you do is, when you have numbers, you do the same as you have when you have variables. Can you see that, people? So whatever K was, you must add 4. Make sense, people? Alright. Let's go with the next one. Number 11. Number 11, we are told subtract the sum of P and Q from the product. What does it mean when it says from the product? Must multiply, not so? What must you multiply? P and Q. So what goes first, the sum or the product? Product must go first. Why? Whatever follows from you, right? First. Okay, for those of you who do English, must not? Sound like you guys good in English. From the product, so it's going to be P times Q, or PQ, yes? Minus P plus Q. You all agree with that? Is something wrong there? The bracket, yes, there must be a bracket. Why must there be a bracket here? That must be done first before you subtract. Can you see that? See, subtract the sum of. So you must add that first and then you subtract it. Subtracting from what? From the product. Okay. And I can simplify this. It can be PQ minus P plus Q in brackets. Okay. You all okay with this, people? Any confusion? Then in number 12 we are told, divide X oranges amongst a number of boys. How many does each one receive? Okay, so what would the expression be? X over A. Okay, for those of you who don't understand, okay, or I could have said X divided by A. If you add 50 oranges divided by 10 boys, you would have been 50 divided by 10 would give you 5 oranges per boy. Not so. It's 500 oranges and 10 boys. Okay? Then what would it be then? Would be 500 oranges divided by 10 boys. Would be what? 50 oranges. Can you see that, people? In the same light as we do with numbers, we do with variables. Okay, you guys understand? Okay. Let's carry on. Now we're looking at flow diagrams. Okay. So a flow diagram can also be expressed as an algebraic expression. Write that down. Wait, I'll give you a chance to make notes now. A flow diagram can also be expressed as an algebraic expression. Okay. And examples of that? You have P that must be multiplied by 2, then you must add 5. Okay, so this should be what? P times 2. That would be what? P times 2. And then plus 1. Okay. You will understand. What is P? Must I add the 2 and the 5 first, or do I multiply this here? Why must you multiply first? Because of odd mass. Multiply first, so it's going to be 2p plus. Any confusion? Okay. So I'll give you a chance now to do number 2 and number 3. I'm going to pause the video at this point. I'll give you a chance to do 2 and 3. Then I will do it on the board. Okay. Okay, so let's look at number 2. What's going to happen here? X minus 3 times 2. Who got that right? It's wrong. What is wrong? Okay, let's say, okay, now nobody's finding that mistake, okay. Let's say x was 2. Or you make it 4. Okay, if x is 4. And I go with this flow diagram. What's 4 minus 3? 1. 1 times 2? 2. So that answer should be 2. So if I put 4 through here, I should also get 2. So that's the same sum, not so. But according to BODMAS, what's going to happen here? What's going to be done first? Multiplication. So it's 4 minus 6. It's minus 2. Hey, so there's a mistake somewhere. What needed to be done first? I must do the? Now here in the flow diagram, what must be done first? Subtraction has to be done first. Not so? So how do I get the subtraction to be done first? I put a bracket around it. Can you see that, people? The bracket needs to be around it. Why? Because I'm going to take that into account now. X minus 3 times 2. What is x? 4. So 4 minus 3 times 2. What's 4 minus 3? 1. And 1 times 2? Can you see? So we need this to be done first. So what we do? We put a bracket around it. Okay? So if we have a multiplication or a division sign following a positive or a negative sign, we must go a bracket around it. Okay, you guys understand? Let's look at the next one. We got a plus 2 plus 3. What do I write? A plus 2 plus. Are they like terms? Yes. So what do we have? 2 plus 3 is? So we're going to have a plus. Can I add a and 5? Why not? Unlike. Right, you guys got it? Nice. Let's go to the next one. I'm moving too fast. You sure? Okay, so I can move a bit faster. Right, number 4. I'll give you 30 seconds, sort number 4 out quickly. I'll see if to pause the video. Yeah. Right, what must be done first? You're going to say it's going to be B plus 2 times 3 minus 2. You all agree with that? Where must it be a bracket? B plus 2. That needs to be done first. Okay? And then you multiply by 3 and then you subtract the 5. You all understand, eh? Who's confused? You all okay? Let's go to number 5. Right. Number 5. I think this is on page 14. Okay, so do number 5 quickly. Right, so what will this be? Y times 3 plus 5. Right. You all agree with that? Where must there be a bracket? Why? Play a bracket here? No. Why? Because that will be done first anyway. Three y plus 5. The bracket must go there. Why? Because what's 3 times y? 3y plus 5. That must be done first. And that answer gets divided by 2. Okay. And we'll do more of this in the exercise now. People, what's the difference between the curve bracket and the block bracket? Doesn't. There's no difference. If I got 2 curve brackets 2, the answer is 4. If I got 2 block bracket 2, the answer is 4. If I got 2 bracket 2, the answer is 4. It's all the same. Okay. Normally we have the outer bracket, which is the squiggle bracket, and then the block bracket. No? But what is the difference? There's no difference. Okay, it all means to multiply. Okay. Now we're going to look at, we need to now draw a flow diagram for the expression. Now we're working in the reverse. Okay. So now we're looking at draw a flow diagram for each of the following. So where we're going to start with? We always start with the variable. So A, what happens to A first? Get multiplied by 4. And then it's minus by 3. You all agree with that? Yes. So anybody that's confused? You all understand, eh? Okay. Let's look at this one. Okay. Where do we start? We start with the variable. So what happens to P first? Huh? What happens to P first? Plus 5. And then? Alright, Right? You guys understand? So for argument's sake, if P was 1, you solve the sum, what would it be? First 6, and 6 times 2 is 12. Can you see? You would have done the positive plus 5 first. Can you see that, people? Right, so that's why we're saying plus 5 first. Okay. So with this, I will stop the video at this point, and you should be able to now do exercise 1 on page 14. Okay.